Have you ever really stopped to think about how you see the world around you? I mean, it seems so simple, doesn't it? You just open your eyes and boom, reality is just there. But what if I told you that what you see isn't just what your eyes are detecting, but what your brain is literally creating for you? Okay, let's get into this, because it's fascinating.
So let's start with a story. This is about the brilliant physician and author Dr. Oliver Sacks, an incredible mind who couldn't do something most of us do without a second thought: recognize his own reflection. Now, how on earth is that even possible?
And that is the big mystery we're going to solve today. It sounds like a total paradox, right? But it actually shines a perfect spotlight on the huge difference between what our senses pick up and what our brain actually understands. It's the gap between just seeing and truly recognizing.
To figure this out, we've got to start with Dr. Sacks's condition. It's a neurological disorder called prosopagnosia, and believe me, it is the key to unlocking this whole thing.
So, prosopagnosia, you might have heard it called face blindness. And here's the most important thing to get. It is not a problem with the eyes. The sensation part, the actual light hitting the retina, that's all working just fine. The breakdown, the glitch in the system, happens in that next step. The brain's ability to make sense of the data. The perception is what's on the fritz.
And that brings us right to the core of this whole explainer. To really get face blindness, we have to pull apart these two processes, sensation and perception. They work together for sure, but they are absolutely not the same thing.
Think of it like this. Sensation is a bottom-up process. It's just raw data coming in through your senses. Light, sound, texture, you name it. But perception, that's top-down. That's your brain acting like a master interpreter, taking all that raw data, organizing it, and giving it meaning. So right now, your eyes are sensing light from the screen, but your brain is perceiving these words and making sense of them.
Now here's the thing. Even that very first step, sensation, isn't as straightforward as it seems. I mean, we are just bombarded with information all the time, but we can't actually detect all of it. Our senses have their limits.
And this brings us to a cool concept called the absolute threshold. Basically, it's the quietest sound or the dimmest light you can possibly detect, but only about half the time. And that 50% part is really important because it tells us our brains aren't just simple on-off switches. Our awareness is constantly shifting.
Right? It's not just about how strong a signal is. Your own psychology, your focus, your expectations plays a huge role. I mean, just think about new parents. They can sleep right through a loud thunderstorm, but the second their baby lets out the tiniest little whimper, they're wide awake. Their brain is primed to catch that specific signal.
And you've totally experienced this yourself. It's really hard to notice a tiny change in something that's already super intense. That's what Weber's law is all about. For us to notice a difference, it has to be a certain percentage of change, not just a fixed amount. You'd definitely notice if someone lit one more candle in a pitch-black room, right? But you'd never, ever notice that same single candle being lit in a giant, brightly lit football stadium.
Okay, so let's track how all this works using our most powerful sense, our vision. We're going to follow the incredibly fast journey that light takes from an object, like a face, all the way into your brain.
The whole process is just beautiful, really. First, light enters through your cornea and pupil. From there, the lens focuses that light onto the retina, which is at the very back of your eye. That's where special cells turn the light into a neural signal, and that signal then zips down the optic nerve straight to the brain's visual cortex to be processed. It's amazing.
And on the retina, you've got two kinds of receptor cells doing all the heavy lifting. You've got rods, which are your low-light experts. They detect black, white, and gray. And then you have cones. Cones are all about the details. They pick up fine lines and, crucially, color. But they need a lot of light to get the job done.
All right, here we go. We have all the pieces now. We get sensation, we get perception, and we know the basic route vision takes. So let's go back to Dr. Sacks and finally solve this mystery of how he can see a face but not recognize it.
This is the absolute game changer. It turns out your brain doesn't just have one big vision department. Nope. It has these highly specialized little modules. And the part of your brain that recognizes your favorite coffee mug is in a totally different location than the part that recognizes your mom's face.
And that super specialized VIP area for facial recognition? It's called the fusiform gyrus. This little bit of your brain has one main job: to take all the data coming in about a face's features and put it all together into a recognizable person. So here it is, the puzzle solved. For Dr. Sacks, the sensation part is perfect. His eyes work, the rods and cones fire, the optic nerve sends a crystal clear signal. But when that signal gets to his fusiform gyrus, the recognition software crashes. He can sense the individual parts, the nose, the eyes, the mouth, but his brain just can't perform that final, almost magical step of perception to see it all as a whole recognizable face.
And that leaves us with one last, kind of mind-bending question. The world you experience isn't just what's out there. It's a construction, an interpretation your brain builds for you. So if our own reality is shaped so deeply by our individual perception, what does that mean for the objective truth we all think we share? Definitely something to chew on.